going to be a very nice day because today I decided to look at some of the things I know many teachers have not been able to bring to your knowledge. Even if you are a teacher, you need to learn a lot of things from Mr. Primus now. We are always learning anyway. We are all still learning. But I would like you to learn a lot of good things. We are talking about the qualitative analysis samples. The specimens have been given to schools and they have been paying much attention on the volumetric analysis, that is the titration, and qualitative analysis, that is on salts. But today I decided to look at that number 3 question, that one that many people do not really have time to look into. And as well, I also give you a kind of simple guide to that qualitative analysis, what will help you to answer many questions in that qualitative analysis, the general knowledge you need to have in the qualitative analysis. If you can have the knowledge, it means that you can solve a lot of other questions. Now, I do tell students that most of the time when you are given a particular question, without performing the experiment, you will be able to, like in qualitative analysis, say, this is the result, this is the result. Now, look at these questions. These questions are based on reduction and oxidation. One of my subscribers pleaded, requested that we should teach this. After that first one, I saw it again and then again and again from different subscribers. That made me to know that this is a very important topic to almost all my subscribers and many other ones. So if you have not subscribed, please do that, and you can always request any topic you want me to teach. Look at these questions now. We are going to answer all these questions. At the end of this lesson, we'll answer all these questions. And there's a way I want to start it. Let's focus on this. Look at this. Here we have 2 salts. These are salts. And these are oxidizing agents. I decided to bring these ones. Oxidizing agents. We acidify them with concentrated tetrahydrosis of acetic acid. When these oxidizing agents come in contact with reducing agents, something happened to them, and I'm going to tell you that. Alright, let's concentrate now. So now, let's look at, says in tabular form, give 2 differences between oxidation and reduction. In tabular form, give 2 differences between oxidation and reduction. Now, before we do that, let's define oxidation. What is oxidation? What is oxidation? And what is reduction? Oxidation. Now, I want to ask you, what is oxidation state? What is oxidation state? I don't want to give the definition as it may be in the general form. Oxidation state involves just the charge. Now, oxidation state of chlorine is -1. Oxygen is -2. Right? Magnesium is +2. Aluminum is 3. These are oxidation states. The charges. So now, what is oxidation? What is oxidation? Oxidation simply means increase in oxidation number. Increase in what? Oxidation number. Increase in oxidation number. So if you have a metal, mainly the transition metals have variable oxidation states. A transition metal like iron 2, we have iron 2 ion and iron 3 ion. When this oxidation metal increases from iron 2 to iron 3, we say oxidation has taken place. Alright, thank you very much for that. So if you have this ion oxidizing, this one is green. When you move, it moves from green, from 2 to 3, it is oxidation. This one is reddish brown. So this oxidation can only be brought about by oxidizing agents. These salts you have here are oxidizing agents. When you dissolve them in water, add concentrated tetrahydrosis of acetic acid to activate it, then you add it to any salt that contains this iron 2. It will change the color from green to reddish brown. That is what the oxidizing agents will do. Now, that is oxidation as I've explained it in terms of increase in oxidation state. Oxidation can also be defined as addition of oxygen. When you add oxygen to any substance, you see that substance has become oxidized. Like if you have this, iron 2 iron 2 oxide. This is iron 2 oxide. If this iron 2 oxide increases and becomes iron 3 oxide, iron 3 oxide, if it gains oxygen, if you add oxygen to it, it can turn to iron 3 oxide. From iron 2 to iron 3, this is also oxidation, addition of oxygen. I hope you can understand that. If you have zinc and possibly at the end you have zinc oxide, this is oxidation. So if you move from zinc to zinc oxide, addition of oxygen to any substance, it is oxidation. I'm not balancing these equations. I'm just giving it to you as it is. Now, addition of oxygen is also oxidation. Now, let's look at the one that brings a lot of confusion. Electron. When it involves electron, gain or loss of electron. Now, let me ask you, what do you think should be oxidation? Is it gain of electron or loss of electron? This is where it confuses many people. Even some teachers I interviewed using this could not answer the question. Gain of electrons and loss of electron. Which one is oxidation? Which one is reduction? Now let's look at this holistically. First of all, what is an electron? An electron is just a negative charge. Electron, a negatively charged particle of an atom. Now proton is positive. Proton positive. Electron negative. Now, when you talk about electron, it is negatively charged. When you bring a negative charge to a substance, what happens to that substance? Now, let me use sodium as an example. If you have sodium, what is the atomic number of sodium? So, atomic number of sodium is 11. So, if we have sodium, permit me to clean this, please. So, as we have sodium now, the number of protons, atomic number is number of protons. So, sodium is 11. So, sodium has, as it is now, 11 protons, 11 electron, proton, electron. That is 0. That will say that an atom is neutral in the normal state. Then, if there is loss of electron, let me say loss of electron. If you remove electron, one electron here, and it becomes 10, that will give you what? Plus 1. So, loss of electron, can you see that oxidation state has increased from 0 to 1? It is 0 to 1 now. Because it has increased by loss of electron. Oxidation is defined as what? Loss of electron, not gain of electron. Have you seen that now? So don't be confused. So oxidation is what? Loss of electron. Loss of electron. If oxidation is loss of electron, then reduction is what? Gain of electron. Gain of electron. By the way, when you remove negative charge, the substance becomes positive. The more you remove negative, the more it becomes what? Positive. I hope that is clear. So if you are writing this one now, you write it sodium ion. It has been oxidized in this form. It has increased in oxidation state. Right? So now, let's continue with this. So now that we have defined oxidation in terms of increase in oxidation number or oxidation state, addition of oxygen and loss of electron, the opposite is reduction. The opposite is reduction. So you can now bring it like this now. You can now bring it like this now. Reduction. Reduction. So what is reduction now? Reduction is what? Increase in oxidation number. What? Decrease in oxidation number. Right? In oxidation state or number. Decrease in oxidation number or decrease in oxidation state. Now, addition of what? Oxygen for oxidation. Now, this one is what? Removal. Removal of what? Oxygen. Now, you can also define it. I want to give you an assignment. Define oxidation and reduction in terms of addition and removal of hydrogen. Which one is addition of hydrogen? Which one is removal of hydrogen? Answer it in our comment section. So now, this one is loss of electron. This one is now what? Gain of what? Electron. Alright. Thank you. Thank you for that. Okay. We'll continue. Thank you for that. Alright. Now with this, let me clean this and do something. What I want you to do now is this. What I want you to do now is this. On your own now, answer this. This will show that you have been able to understand this thing very well. It shows that you have been able to understand this very, very well. This is something you need to know, and it is coming. All right. So give 3 examples. I not say it is coming in Waec. Don't quote me wrong. You are going to miss something like this in different places. Luckily, we may be lucky enough to see it. I've not seen the question, because based on permutations, I can say something like this can come out. So that is why it has been happening. I will say this. I will teach students that expect something like this, expect something like that, and it happens. So I'm not 100% sure. Please, thank you very much. All right. So give 3 examples of oxidizing agents and 2 examples of reducing agents. The 3 examples of oxidizing agents. Now we have seen, I've given you examples of oxidizing agents. This is an oxidizing agent. Potassium tetraoxomanganese 7. Potassium tetraoxomanganese 7. This is an oxidizing agent. Another one is potassium heptaoxodichromate 6. Potassium heptaoxodichromate 6. At the end of this, I will teach you how to balance redox equation. My mind just tells me to do that. I don't know the reason. Just like it happens. Whenever my mind tells me to teach students something, or other teachers, at the end of the day, it becomes very, very useful. So pay attention to the end. I'm going to teach you how to balance redox equation very well, that anyone given to you, you will be able to balance it comfortably. Thank you. All right. So this is an oxidizing agent. You also have oxygen as an oxidizing agent, and non-metals. These are oxidizing agents. Chlorine is an oxidizing agent. Chlorine molecule, fluorine molecule. These are oxidizing agents. Oxygen molecule. These are oxidizing agents. They can carry out oxidation. Non-metals carry out oxidation. Now, reducing agents. We talk about hydrogen sulfide. Hydrogen sulfide is a strong reducing agent. These are strong reducing oxidizing agents. You can also have HNO3 oxidizing agents. So these are oxidizing agents. So this is a strong reducing agent. You also have sulfur oxide, a strong reducing agent. Thank you very much for that. So now this hydrogen sulfide has an oil. It smells like rotten egg. But these two, let's just look at something. If you have these two, what this does is what this can also do most of the time. But if you want to differentiate the presence of, you may have a question, how can you differentiate the presence of hydrogen sulfide and sulfur oxide as reducing agents without using the other? If like other is not involved. So number 1 can be the other. Then number 2, you pass the gas through lead 2 triazonitrate 5. If it is hydrogen sulfide, it will form lead 2 sulfide, PBS, which is black. It will form a black substance, lead 2 sulfide. So if it is this one, it will give you a black, it will give you black lead 2 sulfide. And if it is this one, you may not observe any black coloration. So what you use to differentiate these two is that when you pass any of these two through 725, and if it is this one, it will turn black. If it is this one, there will be no visible reaction in that form. Okay, thank you very much. So now let's continue. I hope you have grabbed the knowledge. That is why in your test observation inference, if you have something like this H2S plus PbNO3 like this, you have this with this. This will give you, in observation, it will give you a black coloration. Now, then this one will now give you a black coloration, a black precipitate, which means lead 2 ion. Or let me just say this one is not here. Hydrogen sulfide plus C as a substance. If something it turns black, this hydrogen sulfide with black will give you what? Lead 2 ion. So you use this thing to confirm the presence of lead 2 ion. So this is your test observation inference. That's why I told you that if you are provided with reagents, you can ordinarily say that this is what is going to be the result, even before performing the experiment. Why? You know it already. You have done it. It's something that you have learnt. That when we say 2 times 3 is 6. So if somebody brings 2 and 3 and tell you to multiply, give the answer without even multiplying it or trying to look at newspaper times. No, because you already have it in your mind or in your brain. All right. So these are reducing agents. Other reducing agents we have are the metals. It matters. But most of the time in the laboratory, whenever we talk about reducing agents, we talk about these two most of the time. Now, so these are, give 2 examples of oxidizing agent and 3 examples of oxidizing agent and 2 examples of reducing agents. I have answered this question now. So let's look at another part, number 3. The number C, very, very, very necessary. Very, very, very necessary. Now look at this one. How can you carry out tests for oxidizing agents in the laboratory? Tests for oxidizing agents in the laboratory. Now, look at this. When you have potassium heptaoxodichromate 6, this one, what is the color of this? You can see it here. This is orange. The color of this is what? Orange. What is the color of this? It is what? Purple. Now, if you want to carry out tests for this, when you bring this potassium heptaoxodichromate 6, if this color, if this thing combines with any reducing agent, it turns the color from orange to green. The color will change from what? Orange to green, because it's an oxidizing agent. It will turn it from orange to green, right? So this is for this one. Then if it is potassium tetramanganate 7, it turns from purple to what? Colorless. Now let me ask you, why would this thing change from orange to green? That is another question. Look at this. If you have this heptaoxodichromate 6, 2 minus, this is heptaoxodichromate 6. I have taught students how this. Okay, let me teach you why is it heptaoxodichromate 6. Now let's use this thing. Now oxygen is 2. This minus 2 is for these 2. It's a radical. So now say call chromate what? We are trying to find the oxidation state of chromium here. We don't know the oxidation state of chromium here. Chromate what? Call it X. Now 2 times X, 2X. 7 oxygen is minus 2. You know, oxygen O2 minus. So 7 times minus 2 plus 7 times minus 2 is equal to this charge minus 2. Yeah, let's find out. 2x 7 times minus 2 is minus 14 equal to minus 2. So 2x equal to minus 2 plus 14. 2x equal to minus 2 plus 14 is what? 12. Divide both sides by 2. Divide both sides by 2 to obtain your x. So x 12 divided by 2 is what? 6. That's why I call it heptaoxodichromate 6. Heptaoxodichromate 6. This is heptaoxodichromate 6. So if this thing, it is an oxidizing agent, I can remember something now. Oxidizing agent. In fact, maybe after this I'll take time to also say a lot of other things under reduction and oxidation. Oxidizing agent. This oxidizing agent is at the end of the reaction becomes what? Reduced. It becomes reduced. An oxidizing agent is that substance that at the end of the reduction becomes reduced. An agent, it will go to oxidize. So when it gives out oxygen, you know, oxidation is what? Addition of oxygen. So when it gives out oxygen, it becomes what? Reduced. You understand? Oxidizing agent will go and oxidize. It will go and increase the oxidation state of another substance. Alright, so this is oxidizing agent. Okay, look at it now. When it is Cr2O72 minus, if it oxidizes another substance, it changes to what? Cr3 plus. From 6 to 3. This is very important. This is very, 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 very important. We are going to use this to balance the Redox equation and this as well. So this is tetraoxomanganate 7. Tetraoxomanganate 7. Like we solved that one. 4 times 2. We don't know manganate. 4 times 2, 8. 8 minus 1, 7. Very simple. The shortest way. 4 times 2, 8. 8 minus, this is minus 1. This is minus 1. 8 minus 1 is 7 here. So that is the shortest form as I do teach students. Just use, like this one now, you can say 7 times 2, 14. 14 minus 2, 12. divided by 2, 6 here. Now 4 times 2, 8. 8 minus 1, 7. We divided by 2 because this one has 2 here. If this one does not have 2, it becomes 7 times 2, 14. 14 minus 2 becomes what? 12. But it has 2 here, so divided by 12 divided by 2 will give you what? 6. Heptadecimal, the short form of this calculation anyway. So I know you have gotten that now. So this is manganese 7. It becomes like this. So it turns from 7 to 2. This 2, manganese 2 ion, is colorless. This is colorless. So as an oxidizing agent, it decreases from here. As an agent, it reduces from 7 to 2. As an agent, from 7 to 2. This one reduces from what? From 6 to 3. So now this one is orange, while this one is what? Green. This one is purple, while this one is what? Colorless. This is how it happens. So this gives you a very good knowledge of this. I hope you are getting this. I know why I am giving you this. You need this. Believe you me, you need this so much. After this, I will also teach you salts, precipitating reagents that will help you to also answer a lot of questions when it comes to qualitative analysis. I'm going to give you general knowledge. Alright, so now that is for these ones, oxidation. And so how can you carry out tests for oxidizing agents? If you want to carry out tests, let's conclude this very vividly. If you want to carry out tests on oxidizing agent like K2Cr2O7, if you use potassium iodide, if you use this oxidizing agent will liberate iodine from potassium iodide. This oxidizing agent will liberate iodine from potassium iodide. The same thing with KMnO4. This will liberate iodine from this. And to confirm that it's iodine, you now add starch solution. Add starch to it. It will give you what? It will give you the color will turn what? Blue, black. That confirms the presence of iodine in this form. Alright, so now let me put it like this. Let me clean this place and show you in tabular form how it is written. Alright, so if you have something like this, you have something like game test, observation, inference, now solution or salt, solution plus potassium iodide, aqueous. Then if you now plus starch solution. Now if you have something like a brown solution, then with this starch turns blue, black. Your inference is what? Let me say solution A plus, which means A is what? A is a what? Oxidizing agent. A is an oxidizing agent. You can put it like this. A is an oxidizing agent. Because it's only oxidizing agent that will liberate iodine from what? Potassium iodide. And when you add starch, use it to confirm the presence of what? Iodine. That is how it happens. Alright. So we'll look at another test. So you can also use hydrogen sulfide, as I said. If you add hydrogen sulfide, let me say plus, let me clean this. If you have, you cut it like this. If you have solution A, another portion, plus hydrogen sulfide. If you bubble it through hydrogen sulfide and you get a yellow what? A yellow deposit. It means that there is sulfur. So it's only oxidizing agent that this thing we change this hydrogen sulfide to give you what? Sulfur. So this one is the same thing. Is an oxidizing agent. So if you bubble an oxidizing agent through hydrogen sulfide, you have to obtain what? Yellow sulfur. Sulfur is there present. You observe sulfur. Sulfur is mainly what? Yellow. It means that it is what? An oxidizing agent. So this is how to test for oxidizing agents. And as well, if you also bring iron 2 chloride, You can also use iron 2 chloride. If you bring iron 2 chloride, FeCl2, or let me just say, I'm going to carry out an experiment on this anyway. Solution A plus FeCl2 or FeSO4, any of these, it will turn this thing. If it is iron 2 tetrosulfate, it will turn it, or let me say iron 2 chloride. Let me just be specific here. Let me use this one. Iron 2 chloride, it will turn it from what? Green to what? To what? Green to brown. Turns from green to brown. Green to brown. It means that what? The solution is also what? An oxidizing agent as well. So this is how to identify reducing oxidizing agents. Now, I want to tell you, okay, now with this thing I said here, the same thing. So reducing agents. What we have here is what reducing agents can do. Alright, reducing agents. If you want to test for reducing agents, pass this. Reducing agent to turn the color of this from orange to green, or this from purple to colorless, as I've explained. I say reducing agent, hydrogen sulfide, as I've explained that. So with this, I think we have been able to answer all these questions. Now what I want you to do is go through these questions again. Try to answer them in writing by yourself and see if you can get it. If you cannot get it, you come back to this lesson. Keep reviewing it. As the more you review it, the better you are. So try to answer these questions on your own to test your level of assimilation of the lesson. Now I want to give you some precipitating reagents, just very few ones, so that in our next class we continue. So for our qualitative analysis, question number 2, as it keeps coming up every year. It keeps coming up. So I think in my next lesson I will use one of the past questions to guide you better, so that you score A1 chemistry this year. So I will use one of the past questions to guide you properly. Guide, remember I said guide you properly. With that, you can always, even in the university in year 1, throughout your days in the university, you'll be able to keep answering questions in qualitative analysis. Alright, so now look at this. Barium chloride. Barium chloride solution will always is used in precipitating tetraoxosulfate ion. Why? Let me tell you, we have some soluble and insoluble salts. I taught it in one of the lessons in this my channel. Alternative to practical chemistry. Check it. You will see. I think the one that has highest number of views so far. Just go and check them. Soluble and insoluble salts. Now, all tetraoxosulfate salts. Okay, in our next class, I'm going to perform this experiment. I'm going to precipitate this. All tetraoxosulfate salts are soluble, except now this calcium tetrasulfate is slightly, take note, slightly CaSO4 is slightly what? Soluble. Now BaSO4, barium tetraoxosulfate is not soluble. So when this barium tetraoxosulfate comes in contact with a source that has this SO4, there will be a what? A precipitate. We are going to perform this. Even when you get this thing, add dilute H2SO4. If I have dilute H2SO4 and get barium chloride, if I put this thing, if I add this thing in drops, I will have a precipitate. I'm going to do that anyway. Now that is anytime you see barium chloride. Now your table will look like this. 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 Now this is test, observation, and inference. So you can now have something like, let me say, salt plus BaCl2. This is qualitative analysis. It is also like alternative to practical. I know it. And that is why some students can answer questions without performing the experiment. If you just see the two, you know the result already. So salt plus barium chloride, and you have a white precipitate. It means that you have what? SO42 minus present. Now you may have plus hydrogen chloride. dilute HCl plus dilute HCl. Precipitate does not dissolve. It means that what? SO42 minus. SO42 minus is what? Confirmed. Because this is weaker than SO4. Cl is weaker than SO4, so it cannot dissolve it. I hope you can understand that. This is a weaker acid compared to H2SO4. H2SO4. H2SO4 is stronger than HCl, so it cannot dissolve this. So when you now see plus the solution plus barium chloride plus dilute HCl, this precipitate does not dissolve. So this is a typical qualitative analysis, both in Waec and GCE. In Waec you have to perform the experiment, but in GCE you need to know it. That is why they say GCE is more difficult than in Waec exam. Yes, because Waec you can practicalize it and see, observe, but you must know your inference. So if you know this, you can answer anything, you can teach anybody on qualitative analysis. Alright, so now if you have something like, now let's look at another precipitating reagent. Another precipitating reagent for acid radicals, not for the metals. In our next class, we are going to look at a precipitating reagents for metals. Okay, let me say it briefly. For metals, we use what? Sodium hydroxide and what? Ammonia solution. So you can use this for metals. Go and find out. Go and check it. It's an assignment. The use of sodium hydroxide and use of what? Ammonia solution. Assignment. Use of sodium hydroxide and use of ammonia solution in precipitating metals. Metals. Aluminum, zinc, lead-2, calcium. Calcium. In precipitating these metals. So how does sodium hydroxide, aqueous ammonia and the rest of them, what are the actions on these? Which one will form precipitate? Which one in drops and in excess? So if you want me to teach this, make comments. Make comment. I would like to do this, but I need you to comment on this. Alright, thank you. I've asked you to go and find out. You do your part, I play my part, we get a good result. Or we get good results. Now look at another one. Silver triazonitrate 5. Anytime you see this silver triazonitrate 5, AgNO3, it means you are trying to precipitate chloride ion. You are trying to precipitate chloride ion, because silver chloride is an insoluble salt. It's an insoluble salt. Now let me tell you very quickly. Any salt that contains potassium, sodium and what? Ammonium is soluble. You may be asked a question like this. They will ask you, they will give you K2CO3, ZnCO3 and NH4 to SO4. Which of the following is I soluble salt, soluble II, insoluble salt? You have to answer the questions. This is soluble because it contains potassium. This is insoluble. The salts of CO3 are insoluble. CO3 salts are insoluble, except those ones that contain potassium, sodium, or what? Ammonium. Every other CO3 is insoluble. So this is an insoluble salt. This is a soluble salt. You'll be given many other questions. The one that when reacts with an acid produces colorless, odorless gas that reacts with lime water to produce turns lime water milky. It can be any of these two. Turns lime water milky. When it reacts, produces a gas that turns lime water milky, is these two. CO2 turns lime water milky. So if I have something like sodium triazocarbonate 4 and I react it with HCl, effervescence will occur. And odorless and colorless gas will be evolved.